Okay, so we're going to show you how we would lay up and make a composite part, but I just wanted to show you kind of how we get to the stage where we're going to be, where we're going to start right now. So these that I have right here are what we call plugs. You can make it out of anything. You can make it out of clay, you can make it out of plaster of Paris, whatever shape you need. And I can't tell you how many people have actually had an experimental part. They needed a fairing or something, or a bubble on the cowling to fit some piece of equipment on the thing. You can make this stuff up. We just happen to be using a CNC router, and we're just cutting out single layers of MDF, and we get them up to the point where we're just gluing them all together, and that starts our basic shape. And then after we've got that, we go to the next stage. Let's just move this one out of the way. Ooh, grab those pliers right there, thank you. And we start putting Bondo on it, and then we primer it, and then we'll start sanding it down. We'll start making the thing smoother and smoother. And so it'll start to evolve into a shape that we can use. And that's the next stage right there. Okay, so next, doesn't matter where you place that stuff, I'm gonna mess it up. Thank you. So next step, here is basically what we're gonna be working on today. Is we have a fairing for the tip of a rudder, and we've got our mold here. We're just doing a little bit of Bondo to finish this thing up, but we're almost to the stage where we go to the next step. And the next step is we're gonna paint this thing with a polyurethane paint so that we get it shiny and hard. And so when we get that done, here's what we're left with. There's that part, but it's down to the stage where we're actually, we've got some paint on the thing. And that paint is just a regular old two-part epoxy polyurethane paint, something like that makes it shiny and makes it slippery. After it's cured, we will wax this thing 10 times. Wax and buff, and we'll get that thing 10 layers of wax. Minimum of 10 layers of wax is the first go around. Once you've got the 10 layers in there, then you're good to go. When we get that part made like that, then what we do is we lay up fiberglass over the top of that to make our actual mold. And that's what we have underneath here, is this part. We just came out and we took just a bunch of really cheap fiberglass mat and polyester resin, which is way too heavy to be used on aircraft, and made a frame so it's stiff. And there's our mold that we've got coming out of the back end of it. So we wax it. We do 10 waxies on the thing. Make sure that when you're using the wax that you don't have any crap in your rags. You're using a soft rag so that you don't scratch your mold that you're working with. And then before you go to do the layup, we're simply going to rub that thing dry. I like to keep wax on it in between the times when I'm not using it. This one is not a perfect mold. Every little scratch, every little divot that you can see in this, that's going to show up in the final part. So we've got this polished up. Make sure you've pretty much got all the excess dust and everything off of it. You can even use a tack rag or some other rag to ensure that you don't have any extra contamination in there. Okay, that's our starting part that we're going to do right there. Now, we're going to be laying this up using, we're going to make this a carbon fiber part. So we've already cut out a couple pieces of carbon fiber here that we're going to use. Let's just take a look at what we've got. A couple pieces here. What I typically do when I'm making these parts up is I'll make myself a template ahead of time that is the size that I want, so I've got accuracy on the part that I'm building. Now I'm using some scraps here. You can see those lines that are in there from that being folded. Remember we talked in class about how that weakens the structure substantially through those areas. But for our class demonstration, this will work great. So I've kind of got an idea where these are going to end up. Let's see if I can get this right. Looks like that way right there. Okay. And I've got two pieces here that I'm going to be working with.
You cut that on the specific direction.
I did actually. You'll notice the way that I chose to do this is I have two different directions. So I have opposed the directions 45-degree angle from each other on purpose because that's what I wanted to do for this one part that's right here. Okay. So let's go ahead and we'll mix some epoxy. Jason's already done it. We're using an epoxy pump here. The epoxy pump is a ratio pump for this epoxy that's specifically set up to get the right ratio. When you're doing this just for 1 or 2 jobs like what you were talking about doing, you're not going to have an epoxy pump. You're just going to get a scale out there and you're either going to do it by volume or you're going to do it by weight in order to get the ratio in there. We're just going to go ahead and lay up right on top of this wax component right here. And we don't even have to be too careful. We're looking for an even distribution of resin throughout this.
And this is
easiest to wet out. What's that?
For carbon fiber, there's a specific type of resin.
There's a lot of resins that will work with carbon fiber. What we're using today, and be real careful about those hairs that I just saw floating around in there. That's no good. Don't want those on the other side. Okay, now we'll take this one, place it right there. Okay. Okay, I'm putting you to work. Start gooping.
So I got a question. Do you want to start from the middle and work radially out to when you start?
This is a really flat part. I've got a big advantage in the fact that it's a really flat part compared to where you've got a lot of really weirdo curves and stuff going on like that. A lot of times you're going to have to lay out very specifically with, like this first piece that I put on here, you see that I've got to cut on a bias for this, my hardest angle that I have to make going up like that, and then come back over and cut that on a bias so that that first piece lays over as cleanly as possible on that one little edge that's on there. When we talked in class about the bias ply tapes and how they form over compound curves, when you start doing large stuff, it doesn't matter if it's bias or not. When it's a large piece, there's nothing that's biased about it. It's just straight and straight, so there's nothing you can get out of it. The best way to deal with compound curves on large surfaces is a loose weave. When you get a looser weave, it starts to mold a little bit easier and it can move in.
Okay. My question specifically was about putting this next coat on, starting in the center of the mold and pulling out the epoxy out toward the edges or are you not worried at this moment about any error or imperfections in that?
And I'm going to show you why. We would like, just like what we said in the class, we would like 100% saturation, not 101, but 100%. We want to get all of that out of it. But we're going to use a vacuum bagging method with some bleeder ply and some peel ply in here that's going to help do exactly what we're talking about. It's going to take all that excess weight out of there. Looks like we're getting close. We're going to lay up the next batch right in here. Okay, have at it.
Somebody asked it.
So the most important aspect, obviously, is to deal with the saturation. Make sure on carbon it's very difficult because it's not translucent. We can't see if there's air bubbles that are down underneath the thing. Now the vacuum bagging that we're going to demonstrate for you is going to take care of some of that. While they're working this in, one of the next steps we're going to be doing is we're going to be adding peel ply that we talked about. And I've cut a chunk here ahead of time. I'll have to trim it down a little bit more. Oh, actually I've got it trimmed already. I went ahead and cut some pleats out of it so that it would lay in there like I thought was going to be necessary. And that's nothing more than a Dacron peel ply that's right there. We're going to have a bleeder ply as the next layer, and that's a piece of plastic with a whole bunch of holes that will allow the resin to come through that, but this will separate out this from the blotter ply. And you can make your own. I'll show you how I made my bleeder ply. They make a tool that you just run over and it pokes a whole bunch of holes in it.
So this goes on next.
That'll go on next. This will be next. Yeah, we'll just do it one step at a time here. And if this ever turns into a video, then you'll be able to go back and review this if you ever need it. Because you'll never do this until you'll never even need it. Where'd that red pair of pliers right there. So all I've got is a little leather punch here. And I put it on the smallest, oops, let's pick that one right there, the smallest hole. And fold it up like this, it doesn't take too many holes in there in order to get all of those perforations. I won't finish with this,
How
but
thick is your final product part going to be?
2 layers of glass.
That's it.
Yeah. Super, super lightweight is what I'm looking for. So I'm looking to, so anyway, that's how I make the bleeder ply, is just by cutting that stuff.
And that's just
My
my
regular old visqueen plastic.
grade of plastic, yeah.
Okay, so I've got a couple more pieces that I have to lay on here because I have a specific design. And we talked in class this morning about cutting this tape on a bias. And so that's what we've done here, which will make this stuff really easy to conform to some shapes. And so I'm going to put this right in here. I have a very specific reasoning and location.
And
where
you're
this-
not doing that for radial purposes or anything like that, because it's already carbon fiber, which wouldn't,
Right.
okay. So this is just to add.
Okay. And my reasoning for doing this layer of glass in here, let's see, right there.
Around the outsides, because that's where the fasteners go, I'm guessing.
When I glue the 2 halves together, and where the fasteners, where this touches the aluminum part, carbon fiber is not a good matchup against aluminum, and it'll cause corrosion and electrolysis to go on there. So these parts will actually provide a barrier against the aluminum, and then when we actually glue the 2 carbon halves together, it's easier to glue the E-glass together than it is carbon to carbon. So it'll provide for a little bit of extra.
So the carbon fiber has the electrical potential, and when you glue it on there now, it doesn't.
Exactly. It's not a perfect solution, but we found that it works pretty good for what we're actually trying to accomplish. And since we're talking about weight on this particular design that we're talking about here, super critical. I would say when this comes out of the mold, if I'm more than 8 ounces, I'm going to be disappointed. I don't want 8 ounces in that piece. I want to see a little bit less than that.
So you said this is just 1/2, so you've got another half mold somewhere.
Exactly. In fact, there's the other half right there in front of you.
Okay.
That's just not finished yet, and it's not ready for the layout. Okay, these guys have done a good job here. We're going to lay in our peel ply next. Let's see if I can get that in the right spot. You'll notice that some of this is not sticking down. And the reason is that carbon is just really kind of work me from the middle out there, and then keep the wrinkles out of there. I'll trim this a little bit here. Need all that extra in there.
So once you put a layer down, you pretty much have to leave it there. You can't pull it out and reposition it.
Oh no, you can pull it out. You can give up at any time you want. You don't have to. And I've screwed up enough stuff where I've had to just pull the stuff up, wipe it down with acetone, go get it. You know?
Okay.
But we like to try and hit it somewhere in the neighborhood of the first shot. You know, it's a little.
Oh, what? The whole thing? Or
that?
just the peel top?
Well, you could even pull the peel ply back if you ended up screwing it up. It's all going to come off there. It's hard to screw up peel ply because it just doesn't do anything bad to it, really. Let's add a little extra piece in there. And you can add this in chunks. It doesn't really matter. It's just going to provide us a ability to suck that resin. And you can see the resin's coming right on through this. Next, we'll go to our bleeder cloth here. These guys are catching up with me here. Cut that to the size I need here.
So now with tacking down the peel cloth, you're not looking to add any additional resin to it. You're just
Sucking it up.
You're just sucking it up.
Yep.
Pushing it.
At this point, it won't even matter because our whole process, most of the resin is going to be sucked through the vacuum bagging process. And that's what we're setting up here to do right now, is the It's the baggy part. So as soon as these guys get that in there good,
Where does the resin end up then?
you'll see here in just a second. We'll end up putting on the rest of this blotter cloth as the next step. I think you guys are good. So, yeah, we'll just make sure this tucks down and gets in all these little holes. This is a pretty flat part, so it's pretty easy to deal with this. Okay, that's the next step. Now, what I'm going to do, I'm going to use this. This isn't the best stuff in the world, but it actually works pretty good. And we're just going to soak the resin up into the paper towels. Put several in there. The paper towels are not just to soak up the resin, but they're also there to provide an air path for that air to escape out and suck all of that air from all the edges around the center. Next, I'm going to go ahead and put a little piece of felt in there, which is even better for sucking air. If that cloth gets resin impregnated, it'll actually seal off an area. So we need to have a section where we can ensure that we're going to get that airflow through the outside of this thing.
That's what kind of mold here.
Well, that was just a piece of felt that I found in a scrap pile of stuff. So, oops. Hold it. Thank you. Okay. This is just some tacky tape here. This will go around the outside.
How many boogers are deleted out?
Well, when the EAA does
That
the
one will
videos, there's no editing at all. And the reason is because they're doing it very efficiently, where they just have two cameras that run, and they go back and forth between the close-in shot and the wide-angle shot. And, you know, if I'm picking my nose or something like that, they'll go to the other camera. Okay, now we're going to put on the final layer here. Grab that side, Jason, just stretch it out with me there. And just go ahead and lay it down loosely right in the center there.
Oh, that is cool.
Stretch the sides. We may have to... The trick is no
wrinkles.
wrinkles, because the
If you have a
wrinkles
wrinkle,
will
you
allow
gotta
air
leave.
to leak through those wrinkles. So that's why this stuff works good, because it's nice and stretchy.
Looks like an elbow from a keto system.
It is actually. We're using polyflow fittings because the polyflow tubing is nice and rigid, and we're I like that. I guess I do like it. Oh, you'll see here in a second. Go ahead and plug in my air pump down there for me.
Oh, there.
Coming on.
It just figured.
Oh, there's a gauge on it.
Now,
That didn't take long.
Oh, it's coming up. It's coming up.
Sorry. Sucking right down.
so let's talk about this. We talked in class about pressure and atmospheric pressure. We normally have 14.7 psi. What are we reading on our gauge right there? How many inches of mercury?
It's oscillating between 16 and 13.
You must have some leaks someplace.
It started out a lot lower than that.
Yeah, we'll keep checking for leaks. Usually when you're doing this, you can hear the leaks.
Yeah, it's going up pretty rapidly now. It's 17 to 19.
It's just a matter of finding these spots that are leaking and stretching them out until the thing goes away.
Really
But we'll be able to get probably 25 inches out of that pump pretty easily,
Yeah, it's
which
getting
means
there.
we're, at least 12 psi. So if we round that to 10 psi that we're working with, and we say we're even if we're only, let's say 15 by 15, what's that in square inches?
15 by 15.
125 times,
225.
yeah, 225 times 10 inches, 10 pounds. I mean,
2250.
yeah, so 2,000 pounds of pressure pushing on that thing right now, okay? There's a lot of force down there, and that's what's allowing all of that excess resin that you see in there to come sucking through that thing. So it's, now when you're working with this and you've got these really tight corners, you're probably gonna have to do a little bit of handwork in here just to stretch and make sure that you're getting it all the way down in those corners. So we're looking pretty good right here. We'll just continue to let it sit here, and it'll sit here and it'll run. We'll probably leave the pump running now for, tonight sometime around 10 o'clock, or maybe even tomorrow morning we'll turn it off. It doesn't really matter. But it'll take, at this temperature, it'll take an hour for it to harden up, and by that time it'll be pretty good. We'll just keep making sure that we're stretching it.
So you're not concerned the void in the paper towel or the blotting material?
What do you mean the voids?
Well, the areas where it's not soaking up
There's no excess resin there.
Oh, I see, yeah. Right. There's nothing coming through.
It's only taking out as much as it can get out of there. Once we're about 100% saturated, it's not sucking any more out of that. So, and this is a good example of where I should have had more blotter cloth. This is about what you'd like to see. A couple of spots in there only, to where there's lots of excess absorption available as you're going.
So what you're saying is those darker areas,
Too much resin in
too
there.
much resin, right?
The good news is I've got this other one in here, and it's gonna start drawing it. It'll just draw it right up to this. In fact, if you look what I've done, sometimes what will happen is the amount of resin it'll draw in, it'll actually draw it into the pump. It'll destroy your pump. So look under the table at how I've got that pump set up down there. Yeah, there's a pressure pot that's down there.
Yeah.
And it draws the fluid into the bottom of the pump and it sucks out of the top. So even if there's excess resin, the resin ends up in the bottom of the pot and we don't send garbage through the pump that way. So, and that's a cheap Harbor Freight paint pot for 20 bucks or something like that. That works really well. That happens to be an official vacuum pump. But I had, here's one other pump that I used to use right there underneath that table. This one was an old compressor. It's the first one you're going to buy for your van that you're going to work with, and it got out of date. So I just took the inlet side off and plugged into the inlet side. And all it is the suction pump on one side and pressure pump on the other side, and you're good. So this works just fine, even though it's a little cheese ball compressor. Now those are about $300 compressors. These are about at a yard sale, 20 bucks. So you can keep your setup. So those students are supposed to be out here. What happened to them?
All right, we're back.
I'm all clear. So that piece of plastic is just an investment cash, right? You have to remove it every time you move it on.
Yeah, there are, you can use them over again, but they make even a silicone-based blanket kind of that goes over the top of the thing. And it's intended to be used multiple times. This, a little bit harder to get away with it. So anybody that wanted to see our status of our mold here, we got it pulled out of the part over here. And you can see we pulled it off with the bleeder ply in there. Now that's all just absorbed in epoxy, but that's quite a bit of weight to be actually pulled out of that part.
Yeah, once it's all stripped down.
Actually, what I need is the air nozzle.
Blow some air under there?
That's the gas system. He's getting more interested.
Another hose over here that's closer, just grab the nozzle.
Too late, I got it.
Wow, that's pretty slick.
That's not slick. Hold your hands out, ready? Get ready, it's heavy.
There's a hole.
Yeah, there's gonna be quite a few. Just my poor installation of the mold and everything.
Okay, so you guys put the match pieces together, right? Is that what?
Yeah, and actually, we didn't even pull the tape ply off of this.